The next set of topics I would like to cover would go under, oh, by the way, I forgot the semicolons, it's just an easy mistake to make, right? But the next set of topics I would like to cover is like fundamental properties of structures. Structs. And fundamental, spell it right. Fundamental properties of structs. Some of them we have already covered, right? So if you have a struct which was declared as whatever went inside there, one of the fundamental properties was that we said that if you, so struct has a name, right, name like that, and that becomes a new user-defined data type in our program, then we can say name and basically create an object of, object in memory which will be of that specific type. I would say type name, right, because this is like user-defined type name object, and we can also initialize it with some, populate the fields with some data if we'd like. Otherwise, if we do not initialize it as a local object, it will contain all kinds of garbage in the actual fields. What else we can do with fundamental, by the way, just another note that the latest C++ standards suggest to use it like this. Just, you don't have to use the equal sign, just use the curly braces for the syntax of initialization. Next thing that, of course, we can take the address of the object, right? So we can take the address of the object and we can pass it to a function like void f, right, which basically takes this type name, which becomes a pointer to that object, p-obj, pointer to object, right? So as always, if you want to explain what everything is in a function prototype such as this, you can find the name of the variable first and say this is p-obj is a pointer to whatever type name that is, right? Type name is just a, just a generic name. It can be pixel or it can be this date, right? That another structure we were discussing. All right. So what else? So we can, and then in order to call function f, we say f, and it takes the object, but in order to pass the object indirectly to that function f, we take the address of it. So taking the address is one of the fundamental properties, right? So we say address of is the operator that's available. All right, so let's have another example. Say avoid set date, right? And this time I will pass date pointer to date 1 and date 2. Also pass them by a pointer, and in order to demonstrate, let's just move this update pixel. By the way, one observation is that update pixel has something to do with pixels. Don't you agree? If that's the case, I already have the header file, so maybe I should place the declaration for update pixels in this header file, right? So I can say, so these are pixel operations, right? And for the pixel operations, I have update pixel, and of course, function prototype just uses the semicolon at the end. So if I really wanted to make everything proper, then maybe update pixel should not belong to the main.cpp, but rather I can go to View, Solution Explorer, all right, and just click and say add another new item and create another CPP file and name it pixel.cpp, and say add this new source file. Basically take this and pass this function, copy and paste it into pixel.cpp. One second. Right, just move it here, this update pixel, into a brand new file. And so instead of defining it here, just define it in pixel.cpp. But of course, in order for the compiler to understand what pixel is, because it has no idea, right, I should basically follow the simple rule, just basically include pixel.h in the at the top of this file, and just tell it, look, there's a pixel.h. It has these definitions, one for the pixel structure, another one is the prototype of this function. So now main will be able to access the prototype of this function, and that's all it needs to be able to call it. But the actual definition goes to something called pixel.cpp, which is quite appropriate, I think, right? So this is our global function, update pixel, and it does whatever it does. It probably needs some documentation. So likewise, if I'm switching to work with my date, the concept of my date, which is right here, I'm thinking about a function named setDate, so I can move its prototype into the header file right here, setDate, whatever, just for the sake of demonstration, right? So setDate, apparently it may somehow work with two dates. That's why I'm trying to pass two pointers to the date object. And of course, I would not hesitate to go right in and again go to View, Solution Explorer, just add another source file, add a new item, and this is a source file, and name it date, date.cpp, add it, and then basically provide the definition of this function inside date.cpp, and likewise it needs the header, and so that it knows what date is, and it may look like this in my case, right? So just marking the end of it right here. All right, so what this set date could do, if I wanted to work with these dates, what I could do is that I could say 1, of course, dereference 1 equals dereference 2. What this does is that if I have two dates, and let me create them, user-defined data types, I can say date DT1 for the lack of the better name. How about this? I can say today, right? Today, and say, I don't know, January 1st, 2015, right? And say date birthday, right? And say this is, I don't know, February 2nd, 2010, something like that, right? All right, so I have two dates, today and the birthday, and then I would like to call function name setDate, which is declared in the date.h, right? This is the prototype of the function. It's using the structure. The structure has 3 integers in it. The definition of the structure is in date.cpp, right? And if I want to call this function, I can say setDate, right? And basically pass the two dates that I have, and I can say birthday, comma, today, and what that should do, it should actually, oh, and by the way, since the function is expecting addresses of the two dates, of course, I need to say, take the address of birthday, take the address of today, right? It just makes sense for me to create two of these objects in the scope of my main function, but then say I want to actually manipulate these dates somewhere else, like in this set date. All right, so let's have a quick demonstration of what's happening here in memory. So, all right, so what we have is we say date today, right, and we initialize it with something. Then we say date birthday. We also initialize it, whatever, right? But these two variables are created on the stack frame that belongs to main, right? So main function gets access to its own stack frame, and of course we have three components of the two of these dates, just like that. It's like month, day, and year, month, day, and year, right? So we have these two. Then, of course, we want to pass those two structures, birthday and today, to set date, right? So we invoke set date, and what we do is that it gets its own stack frame as soon as it gets invoked, but what we pass to it is basically the address of, right, the address of today and the address of birthday. So basically what it gets is the two of these addresses, and the two of these addresses essentially pointing to the original two structures. Then inside this function set date, we say 1 equals 2. So we want to assign whatever the value came in date 2, we want to get all of the integers and at once assign them to another object, right? So obviously what we do is that we dereference 1 equals dereference 2. So what dereference does, it basically makes the compiler to use these two addresses but use the actual object to work on, right? So essentially what happens as a result of this assignment is that the value of this is given to the value of that, right? So essentially all these bits that populate the structure 2, whatever that structure is, are transferred to that structure identified by 1, right? And this gets repopulated. And then, of course, set date returns, right? So once it returns, this is gone, right? So this is all gone. We're back in this main function, right? So this assignment has already happened. So we're back here, but the net result is that this specific structure got updated, okay? So, and it got updated in that function call, set date or whatever that was. So what happens here, it would be the same as if I said in my main function, birthday equals today. So the assignment of objects which are created as a result of the structure definition and creation of these objects as variables is available. So since the day of C, you can assign one object to another object. Of course, they have to be of the same type, but what compiler does, either when indirectly accessing our object by this statement inside our function, or when directly executing this assignment, it basically takes all bits of today and transfer them, overlays those bits, zeros and ones, on top of another object, and wipes off the old values and saves the new values in the new object, in the object on the left-hand side of the assignment operator, right? So just like we assign integers, this virtually assigns all three of them, right? So it does and assigns all three of them. If this wasn't available, then if this assignment by default was not available, my choice would then be to do something tedious like birthday equals today dot right? And I have to do this like 3 times. I could go and assign individual integers like dd, and year, whatever that variable is, right? So essentially, what this does is equal to these 3 statements, right? So individual assignments are for individual data members of my structure, but the C compiler allows assignment of these structures just like that.